For 50 years, the Nobel Conference at Gustavus Adolphus College has hosted preeminent scientists, theologians, and ethicists to discuss deep questions in the intersection of science and society. From the newest results in physics, chemistry, and biology to the newest fields of multidisciplinary study, scientists at the Nobel Conference have examined the universe at its largest and smallest scales, explored the oceans, and described new materials. Conference speakers have debated the mechanisms of aging, as well as science and economics of food. Often, speakers have given us a glimpse of the next big questions and how they might be answered. Throughout all of the conversations, ethicists and theologians have grounded the science in a human dimension. The 50th Nobel Conference at Gustavus is celebrating a half-century of bringing breakthrough science to lay audiences in the upper Midwest, across the country, and recently around the world. Nobel Conference 50 is assembling previous Nobel Conference participants to look at recent advances and future directions in the physical sciences, evolutionary biology and ecology, medicine and physiology, and the intersection of science and public policy. Antonio Damasio is a university professor and the David Dornsife Professor of Neuroscience at the University of Southern California, an adjunct professor at the Salk Institute, and heads the Brain and Creativity Institute at USC. Dr. Damasio's research focuses on the relationship between human emotions, human rationality, and the underlying biology. We hope you enjoy this year's presentation by Antonio Damasio entitled The Consciousness Issue.
Thank you very much for your introduction. Thank you for inviting me. I had a wonderful time 20 years ago, I think, when we were here for a conference on the brain alone. So this time we're sharing it with many other topics, which is perfectly fine and, in fact, more interesting. The topic that I chose for this talk this afternoon, consciousness, and specifically this title, The Consciousness Issue, it's really about thoughts around the research that one is conducting on consciousness. I'm not going to give you the solution to the puzzles of consciousness, that would be too pretentious to even want to do it, but I would like to discuss some of the problems that we are facing. And I thought it was interesting, since the main theme of your conference is what to expect in the future, and given the fact that we have this outstanding progress in biology in general and in neurobiology in particular, it's quite intriguing that consciousness remains a problem. Consciousness remains a problem that is unsolved, and very often when solutions are presented, it turns out that the solutions are provoke enormous contention. And this happens, for example, with neuroscientists that have certain proposals that are not only questioned by colleagues, but questions, for example, by philosophers, and even philosophers, for example, Pat Churchland, who will be speaking after, has presented numerous talks and writings on consciousness, and she has been questioned even by philosophers themselves. So there's something very peculiar about this problem, and I would like to talk a little bit about it. This is something for those of you that are in academic careers. There's an old advice, and that is never tackle the problem of consciousness before you're tenured, and even after tenure, you're risking quite a lot of your career and reputation. So I think for over 20 years I've come back to the problem of consciousness. I think that some go on to the next slide. And I'm going to divide this in some problems. They're not ordered in a very profound way. They could be reordered. But let's start with this first problem that faces those of us that want to study consciousness, and that is that consciousness has a profusion of meanings. So if you read about consciousness, or if you have conversations with people who will ask you, because you're a neuroscientist or neurobiologist, so what about consciousness? How do we get to have it? You realize that people don't have at all the same idea that you might have at that moment. For example, they can be just referring to mind by itself, or they can be referring to mind with subjectivity, with this ability which is automatic in a mind that is functioning normally, which is to know that you within your mind is sensing, seeing, and that you're the surveyor of your world. Now, both the notion of mind alone and the notion of mind with subjectivity are really referring to something very, very deep, and that is the notion of mental experience. If there is something that could be shared when we talk about the problem of consciousness, is the fact that we need to elucidate how come our brain in our organisms is capable of generating a mental experience, and that mental experience has automatically, if the function is normal, this sense that there is an owner in your mind that is doing the survey of what is coming into that mind and of the operations that are being done in that mind. If you are, for example, mind walking through your past and reminiscing. Now, very often there will also be references and people will be thinking about mind in the sense of mind with autobiography. Or if you were trained as a neurologist, as we were, there will be this very, very specific sense, which is sort of consciousness at the bedside, which is awareness of self and surroundings, and very specifically this notion that you as a subject are awake and you're oriented to self, to time, and to place. Curiously, this sort of changes the position. I was giving you earlier, when I talk about mental experiences and the mental experience with subjectivity, I was giving you the definition of consciousness, or the problem that one could investigate in consciousness from my perspective, from my interior perspective. But if you are a neurologist or a psychologist and you're being asked to say, is this person conscious or not, what you do is apply a variety of objective criteria that in the end up addressing the issue of what is going on in the mind of that particular person. So if you are awake, and you need to be awake to be conscious in the strict sense, and if you are oriented to yourself, which means you can say who you are, and give some other details if you're asked. And if you know roughly the time, you don't need to give the minutes exactly, but you need to have the sense of which day you're at, unless you're jet lagged like I am and you've been flying around. And if you know the place, then you are oriented to self, to time, and to place, and people will say you are conscious, which means that you are not asleep, you're not comatose, you're not in persistent vegetative state, and that actually is a very practical definition, but it doesn't really immediately pose the problem that we in neuroscience and neurobiology in general, or in cognitive science, if you will, or in philosophy of mind want to address. And then there's also another curious sense about consciousness that has come up more and more, especially from the side of general biology, and that is that maybe consciousness is very simply, and starts very simply, with the notion of feeling, the notion of sensing. At lunch, I was with a wonderful group of high school students, and they asked me something quite interesting. One of them came to me and said, well, what about plants? Are plants conscious? Because plants do sense, in certain circumstances, things that are in the environment. And I was very happy with that question, because I actually do think that if you are going to organize a scale of all the phenomena that could contribute and qualify in a certain way for what we eventually call consciousness, I think the kind of sensitivity / irritability that you find in plants, not just in the ones that are carnivore plants and that sort of respond with movement, which is very rare because they don't have neurons, they don't have action potentials, they don't have muscle cells, except very rarely. But if you want to encompass that, then you have to extend this to the botanical world, and you end up with very, very interesting beginnings that normally are ignored when you discuss consciousness. So this first problem that I wanted to tell you about is that if you engage in a conversation about consciousness and if you're hearing a discussion about it, try to find out what your interlocutor is really thinking in terms of the problem. What are people thinking about among these several problems that I listed? A second problem that is very intriguing, and this morning Pat, actually in the question that she asked Steven Weinberg, brought it into our conference, is this traditional intuition that mind processes cannot be fully accounted for by the materiality of neurobiological phenomena. Part of this, very interesting, it's a very old intuition, which doesn't mean, and very old and very reasonable. Why is it reasonable? Because when you think about it, you look into your mind and you realize that it is prodigiously rich. You have this ability to have a large scope of contents coming into your mental process. It's sort of the Emily Dickinson problem, this mind wider than the sky. You have all of these contents that can very swiftly come into your mind. You can change them very rapidly. You can attend and focus on one particular problem or another. All of this very swiftly, very richly, and then you look at the traditional view of what a brain is, this sort of lump that we carry in our skulls, and the idea that yes, there are neurons, there are these complicated structures, but could it be that it can produce this enormous wealth, this enormous beauty and richness? And people have doubted this. People have sensed that there's something of a different order. And of course, this is very classical. Certainly the Athenian philosophers were very aware of this possibility of this split. Closer to us, there's the classical distinction made by Descartes, none of which makes that distinction just because it is intuitive and it is reasonable. It doesn't make it right. And in fact, I do not think it is right. It is the fact that we have only now been able to cope with the enormous complexity of the brain and what it can do that allows us to imagine that in fact it can produce that enormous wealth that we carry in our brains. So this next part of the slide talked about this contrast between the detailed descriptions of mind and this limited view of what brain tissue can accomplish. And I think that in this audience, which is obviously very sophisticated and informed about science, this is obviously an argument that doesn't carry. People are quite aware that there is a wealth of functionality in our brains that can, in principle, or that should not be denied in principle, the possibility of creating the wealth of mind. And one way in which people very often put this is, how can the activity of neurons account for that mental experience that I mentioned when I started? How can it account for the experience of subjectivity? And if you do, as some of us have tried, and if you say, yes, it can, and you start talking about it, you're very often accused of being reductionist and not being able to realize the different order that you're dealing with when you deal with mental experience. And I think you're dealing with a different perspective, but not with a different order. And you're being accused also sometimes of being, of disregarding the enormous dignity and the enormous status that this extremely sophisticated mind process that we humans have entitles us to. And of course, we're doing neither. There's absolutely nothing by understanding how the brain can produce mental experiences. In no way are you reducing the dignity of human beings. A third problem to consider. The fact, and this is now very serious and the most important of the ones that I've mentioned, the fact that there is a disembodied conception of mind that is separate from the living organisms that gave rise to it. What do I mean by this? Unfortunately, the majority of accounts, until quite recently, that have dealt with the problem of how minds are being produced within the brain are literally about that. They're about a brain alone and not a brain inside an organism, which is absolutely essential because we don't have brains separate. Again, just to tell you how wonderful questions I got at lunch, again, someone asked about a brain separate from the body. How could it operate, and would it operate well? Would it be connectable to some other organism, and would it help? And the answer is that no, it cannot. First of all, brains operate in situ within an organism, and for a very specific reason. They're there, and they were constructed by evolution in order to organize the life of that body, to organize life regulation, and to permit bodies to survive. So it's not that the brain is there to allow us to have Nobel conferences and to allow us to discuss politics or economics to begin with. Of course we can do that too, and write music and poetry and go to the moon. But to begin with, that's not the function of the brain. And so what has happened is this very bizarre thing, is that people treat brain physiology as if it starts at the level, for example, of language, or in connection to processes of language, or processes of fine perception, and of course, or reasoning, and that's very, again, understandable because we are languaged creatures. Language is our main way of transferring information socially, and it's dominant in our culture. Fine perception, especially visual or auditory, is extremely important as well. And that is also something quite remarkable that led to this very strange event. If I were to ask you, do you know where the understanding of brain and mind relationships began scientifically, and I'm not going to put the question so as not to have you struggle with this problem. I'll tell you what the answer is. It actually began in the middle of the 19th century and began with understanding what were the parts of the brain that were involved in language processing. So, amazingly, in the middle of the 19th century, before the discipline of linguistics was even formed as such, there was quite a lot of knowledge about which parts of the brain were more involved with language processing, including the distinction between the parts that were more involved with syntactical processing or with noun selection. This is absolutely astonishing. It was there before you even had Mr. Saussure come into the scene and tell us about the organization of the discipline of linguistics. And visual perception was studied next, and reasoning processes were being studied long before people that were interested in studying the general economy of an organism, such as, for example, Claude Bernard, or for that matter, William James, a very fine both psychologist as well as physiologist and philosopher. Long before them, there were these studies about all these other aspects, all these instrumentalities of our cognition. So it's not surprising that we have been looking at the world upside down in terms of the science, and that we started literally constructing the edifice of the science of mind and the science eventually that has to do with consciousness, as if we were starting to build a house from the roof and then get the walls and eventually come to the foundations. And of course, houses built like that have a way of collapsing. So let me give a biological context and tell you where I think one should start. One should start with the fact that we do have brains that existed physiologically, that existed evolutionarily in order to accomplish a very important role in terms of homeostasis. And those goals include, this is a very brief survey, include immediate life regulation, for example, energy procurement, the running of metabolism, include the maintenance of the integrity of the soma through a variety of defense mechanisms, include, very importantly, social regulation, because it's important to note that we don't actually have individuals appear on this earth alone. They at least have to have some kind of progenitor, and they are there with the social regulation occurring very, very early on, and so that is part of the homeostatic machine, and there's an aspect that has to do also with species continuation. Now, the goals of homeostasis, when you look at it with today's perspective, are implemented via action programs. So there are all of these different series of actions that occur, and this occurs throughout the phylogenetic scale, and of course in the creatures that are closer to us and in ourselves, which is the case that is more pertinent today, they are still action programs that are very complex and that solve complex problems with standard, very elaborate responses that do not require deliberation. Now, the fact that to begin with they do not require deliberation does not mean that it is not an advantage to have deliberation in some cases. So in fact, most of our basic homeostasis is accomplished without deliberation, which is good, but a lot of our more general homeostasis, the one that encompasses our social space, does require deliberation, and that's where, in fact, the whole issue of consciousness gets a particular intensity because it is very different, for example, from the life regulation that a simulation of a human being in a computer system would have, precisely because that consciousness aspect is going to be lacking in those organisms, quote unquote, that have been fabricated for the purpose of a simulation and for further study of the situation. Now, all of these programs that I'm talking about to begin with are preset, call them innate, instinctual, doesn't make any difference, and they are, certainly in our case, open to learning, which can expand the deployment, for example, through conditioning and habits. And a lot of what I'm going to tell you in the next minutes about the issue of feeling and its centrality to the building of something that we could call mental experience has to do with the fact that they are essential if there's going to be learning that is important for life regulation. Now, very briefly, the varieties of action program that we normally deal with, and there are many ways of classifying and presenting this, would include things such as drives, motivations, and emotions in the proper sense of the term. I'm not going to elaborate on that. I'm just going to say that a lot of what is included to begin with are appetites for food, drink, sex, the appetite for exploration and play, the drive for exploration and play, care of progeny, attachment to progeny and mates, just to give you an idea of action programs that are extremely robust, that are present in numerous species, not just in humans, and that are there to arrange the way our life is being deployed, thanks to an action program that is very fixed and that is passive. You know, it's possible to alter it a bit, but it's there as a resource for us, and it can be then further modified by learning if we have a very important cause to encroach on it and to modify the deployment thanks to what we know as conscious individuals. Now, and here comes the central issue. Let me drink one bit of water, please. So all these programs that I'm talking about, you know, the ones that you could find in an experimental animal in the lab, or that you can find, for example, in the jungle, all of these programs, these action programs that run your homeostasis, that is the foundation of the house that is going to end up being conscious, all of these programs are valenced. What do they mean? I mean by this, that they produce body states that are experienced as feelings, that those feelings range from pleasure and well-being to malaise and pain, and that the experience is necessary for life regulation. So basically the core of my talk, or at least the core of what is behind my views on consciousness and mind and experience are contained in this. If we disregard this, and this, quite frankly, is normally disregarding in conversations on consciousness, we're disregarding the beginning of the foundation. So, the programs are valenced because this is not about something that you could have or not have, about something that, whether it works well or not, will still allow you to survive. This is about something on which life depends. And if it is badly run, it will lead to disease, to malaise, it will lead to pain, for example, and can lead to death. If it is well run, and if it can produce well-being and flourishing, then it can be good for that particular individual. Now, when it comes to the conscious running of these programs, we rely on the fact that we feel how the machine is operating. This is inevitable. And I want to point out that this is there as a necessity in the machine. It is not something that we can have or not have, it's there. The governance that is produced, to be very blunt, by either pain or pleasure is a necessity in living organisms, or those living organisms are not going to be there. So it's absolutely critical, and I think that the way I would like to see the beginnings of mind and experience, that is mental experience, and eventually the foundations for consciousness in a more general sense, require the presence of this machinery that is going to give you feelings that are positive and negative. There is nothing neutral about this. They have to be one thing or another in this range. There is the range of parameters that is compatible with life being maintained in such a way that it can continue. You might say, well, okay, that's fine, but you're really imposing it, and what does it buy you? Can't you run this machine without having feelings? Well, yes, you could run it in a way in which you would have the machinery without having the feeling, that is the experience. The problem is that then you wouldn't learn. And if you want a very cursory description of what feelings buy you, what they buy you is the possibility of learning. They call the possibility of learning and the possibility of behaving in the best possible way, because they make you attend, they force you to attend to a condition that may be advantageous or disadvantageous, and that, of course, is fundamental if you're going to have reasoning into the future and you're going to make predictions about what the future is going to be, good, bad, or indifferent. And it is something that is extremely important, therefore, to guide the machine moving forward and to learn. That is an advantage. So, the strategy that I would like to use to deal with this problem, and I'm not making any claims that I've solved the problem, I'm just telling you how I think that I prefer to think about that problem, and let's see what can come out of it, because I certainly don't have all the answers. I would like to separate the issue of general mind-making from the making of subjective experiences. This is going to be very critical. So the general mind-making is what I think a lot of the very important contributors to the problem of consciousness have been doing largely, with limited results, or with results that are very often contested because they're seen as not solving fundamental problems. And then further separate mind-making directed at the exterior from mind-making directed at the interior. And I'm going to try to explain what I mean by this. So let's think about very rapidly about externally directed senses, and take vision, for example, and how we deal with a problem. Because this is certainly the way in which most of the texts on and articles on the problem of consciousness begin. How do you deal with, for example, being conscious of something that you see? Well, in very simple ways, we know today, and there's a very extensive literature, we've dealt with it, on visual maps that we create, in the case of the human brain, in visual cortices, which you can see here, and also in something that we didn't put in the slide, which is the layers, the superficial layers of the superior colliculi. But quite importantly, we also deal at the moment in which we are seeing, I'm looking at you as an audience, you're looking at me, in addition to the visual maps that are being constructed in the visual cortices and in the superior colliculi, and of course before that in the retina, we also have a lot of very complicated things going on. For example, there's an adjustment that I have to do in my lens and in the amount of light that I admit into my retina, which is caused by the fact that I'm looking at a dark room and now I'm making an effort to see you, and this has changed. Now, my brain is registering that at the same time that is generating the visual map. There's also activity of my eyes within my head. There are eye movements that are required for me to take in the audience. There are head and neck movements. All of these are being co-registered in the brain, but marvel of marvels, they don't go into the same place in the brain. Whereas the visual maps end up in visual cortices, and they're created there in a very complicated hierarchy of structures that then merges into the first hierarchy, then an heterarchy of structures. These other things are ending at different points of the brain in what, for the lack of a better word, I decided to call the body phantom. Now, the body phantom, by the way, is not the homunculus. We're not dealing with the homunculus of sad history. We're not dealing with infinite regresses into a homunculus. We're dealing with a possibility of registering events in your body in structures that appear, for example, in the lateral somatosensory cortices, which you see here and here, and in the motor cortices as well. There are also eye fields which are about there and which are not marked here, in the cingulate cortex, even in the insular cortex. All of these regions are in fact co-registering all those other things that I'm doing when I am in the act of seeing. So seeing is not just about vision maps, it's also about a variety of other things that coexist and that are giving you, whether you want it or not, a sense, for example, that you're seeing from your head, and that the information that is critical is not arriving, for example, in the middle of your back, it's actually arriving in your head in very specific places. By the way, if you turn to hearing, it's exactly the same problem. You have the pavilion, you have a variety of things that are happening in the auditory canal and into the cochlea that are, again, not part of the mapping that you get in auditory cortex, but mappings that you get in brain stem all along the chain, and that make auditory processing not just about sound, but about sound and a variety of things that are happening in the body at the same time. So, the process doesn't stop there in case of vision, let's say, because then you have the possibility of distributing the information into, for example, cortices that are of association that allow you to have storage, memory storage of events that are visual, that allow you later on to have memory recall, that allow you to have a governance, for example, from structures in the frontal cortices, and you also know that later on you have the possibility of operating on those contents from a variety of networks that are now fairly well plotted in terms of the first the hierarchical regions that can deal with these different contents, and then with the manipulation that they can have internally. Now, let's turn around into interoception, into the body senses, and make the point that this is a completely different world that we're going to be plunged in, without which we cannot really get, I think, to the problem of experience. And why is this world so imposingly different? The first thing is that I'm going to walk you, as much as I can, through the problem of interoception, how you sense the state of your own body, which is, of course, the critical set of operations if we're going to have homeostasis. And if I compare it, without further ado, with what we were talking about in relation to vision, there is one fundamental problem, or one fundamental difference that I'm going to point out. If I see you and I make maps of you or vice versa, there is no way that my maps and my brain is going to interfere with you as an object unless I decide that I'm going to come to you and shake your hand, for example. But there's no power in my brain to respond to you as a source of perception. However, when you look at what is going on in my heart or in my gut at this very moment, there is a way of representing those body states inside my brain, and lo and behold, my brain responds immediately by return of mail into those regions and changes the state of those regions. So what you have here is a very asymmetric situation, one in which the way in which the world comes into your brain goes this way and then can be registered and manipulated. That's all fine and well. But the way in which your body is registered in your brain is through an arrangement that I prefer to call a compact, that allows the body to be registered in the brain and the brain to influence the body directly, both humorally in terms of chemical molecules, as well as in direct responses via the neural channels that can act on the body. So let's walk a little bit through this. So first, of course, there's this marvelous chain that is now fairly well known, where you have information that comes, for example, from the body at the level of the spinal cord, then at the level of the trigeminal nucleus in relation to the face, that can also come directly, bypassing the spinal cord, through the vagus nerve, and that lands in this region that you have here, which is the region of the brain stem and of the hypothalamus, which is actually the core, the region of the highest interest for us if we're going to understand how you build a platform for subjective experience. There's also the fact that outside of all these neural channels, there are ways of entering this system that I would like to learn how to make the arrow go the way I want. Anyway, so there are ways of getting into this system, for example, through the area postrema, which picks up on molecules that are circulating and can influence directly the neural machinery. And there are also higher up ways of acting through the circumventricular organs into what is going on in the higher part of the system. So we have a way of building this information in a very complex and rich way, and mapping all sorts of parameters that range from rhythms of the heart and breathing to what is going on in the state of contracture of a smooth muscle, and a full array of chemical molecules that are governing the way in which the system is operating. So it's a very rich map, very complex, that you can make of the body proper. And by the way, the wealth of nuclei that are in the brain stem, this is, by the way, a diagram of human brain stem and its critical nuclei. The wealth of governance here is certainly a very good match for the cerebral cortex, except that it is of a different size and it is highly conserved in the evolutionary scale, whereas the cortex is not. But fundamentally, the wealth is enormous, and the interconnectivity of these organs is enormous, and I'm highlighting that interconnectivity here by calling attention to the main partners, the hypothalamus, the periaqueductal gray, and in this case, the deep layers of the superior colliculus, the parabrachial nucleus, the nucleus tractus solitarius, and the area postrema. All look at the arrows, because what is interesting here is just like in the cerebral cortex, where there is convergence from one region to another and then a response of divergence from the region that was touched by the convergence. In here, you have exactly the same principle in operation, and you have a very deep recursive arrangement, so that there is a possibility of a sort of infinite looping of these structures, and you literally create a compact of the representation of the body at any given moment in all of these parameters. And to make the point once again, you have the possibility of interfering in the body proper at the moment in which something like this happens. If you have pain being generated out of a particular position, point in your body, you have the possibility automatically of responding to that and modifying the state of the object that gave rise to the perception of pain. And by the way, all of this machinery can be influenced by the cerebral cortex. So when you hear a piece of music that you can describe as highly emotive, you will in fact have the possibility of influencing the machinery that operates your body state by the fact that you had an emotive process that engenders a change within this body compact. And likewise, if you are perceiving something that produces what you later will call horror or the sense of beauty, you will have the possibility of influencing this machinery, which really gets us at that very question that Pat asked Steve Weinberg, and I think that he answered the question beautifully in the second part. In the reference to qualia at the beginning, I didn't like because I think it's wrong, but we agreed perfectly well that there are things in this huge complexity that can be explained at the level of brain operations, including something as complex and as intuitively difficult to explain as, say, the experience of sublimity. Okay, let me add in the minutes that I have to this, to just make a couple of points. We are at this point, if we are going to endorse the idea that we're going to build a mind, a mental experience and subjectivity out of a platform that you create, and that platform is the platform of body operations necessitated by life regulation and with feelings as a centerpiece. We have become very interested in looking at what could be there in neurobiology that could tell us about why feelings are different from other things. Well, one reason why they're different is that they deal with the body, so the things we feel, the content of our feelings is always about a description of a body state. Whether we are describing a feeling of elation and pleasure and relaxation, or a feeling of tension and fear and anger or hatred or what have you, you are describing always, whether you are a poet or just a person who has learned how to describe himself or herself, you are describing body states, which you then attach to a particular content that produces that state or may have produced that state. But you are describing something that is happening in your body as a result of a certain stimulus, whether that stimulus is emotive or can be, for example, a state of your body that led to pain or pleasure. So what is the particularity beyond that? What is the particularity of it? What could be there that is different? We got very intrigued by this. I reflecting on all of these systems over the years, I've been struck by the fact that the majority of the channels, neural channels that bring information into the central nervous system are in fact unmyelinated. Now, this is very intriguing when you think about it, and we sort of reviewed the literature to make sure that this made sense and it was not just a false impression. Well, it's not false at all. In the majority of those systems that I pointed out to you that bring information into the central nervous system, 80% or more of the fibers have no myelin around the axons. Now, this is bizarre because, of course, in evolution, myelin is a great acquisition because it insulates the axons, it makes for faster conduction, although it comes at a price because it's very costly to plant, to roll Schwann cells around axons to create the insulation of myelin. But it's generally regarded as a positive thing. How interesting that the very system that deals with our life regulation and therefore with survival has completely shunned myelin, or almost completely, paid no attention to it and continued the way it is. Now, there's one very simple possibility, is that it would be so costly to institute a myelin program that nature was smarter and didn't do it. Possible, but I don't find that a very attractive idea. I think it may be that not having myelin confers on the system something that is advantageous, and that's the hypothesis that we are currently investigating. And I have a little cartoon here just to point over there at the top and to point here to bring home the main distinction between these two types of axons. If you have down below an myelinated axon, you can only influence the axon at the nodes of Ranvier. But if you have instead an axon that is denuded and devoid of myelin, you can have ligands that can influence it all along the way. And then you have something that is even more intriguing, and that without a doubt is happening, is that when you pack axons that are not myelinated next to each other, you have a possibility of conducting electrically orthogonally to the length of the axon. So you're going to have something which is called ephapsis, as opposed to just the synapses that could operate at the end into the next neuron. And there's no doubt that ephapsis is a real phenomenon. It's in fact, sadly, for people who have myelinated axons and lose the myelin thanks to a disease called multiple sclerosis, it becomes a huge problem because ephapsis makes those neurons operate badly and becomes a defect. But it could be that ephapsis is one of the many contributors to this very special state that we generate when we have feelings. So let me close by proposing, and this is something that you're very free to disagree with and to add on to or to subtract, to propose the possibility of a subjectivity platform that would be created by this body-brain compact, and that would, of course, bring general interoception from brainstem, hypothalamus, circumventricular organs, and then have this other structure, this body phantom that I talked about, that includes motor cortices and somatosensory cortices, of course the supplementary sensory area, area 8, which has to do with visual eye fields, the insular, the cingulate, the supplementary motor area. So we would have a possibility of not only feeling in general, but you would have the possibility even of localizing feelings. So for example, if you're feeling sick, you have the flu, but now it so happens that you also have a headache. It's interesting because it's still a feeling, but you're going to be able to place it here. And if you have a colic, you will place it in your tummy. So there are these layers, some of which, of course, are likely to come out of the brainstem hypothalamic level of the operation, which is the older and the one that is shared with many other species, and another that is coming out of other levels, more cortical, and that will give you even a localization for what is happening within your somatosensory system. And we're going to skip that. I'm going to skip that as well. And I'm going to close by saying that if you have this, you have the possibility of creating what I like to call second-order maps. So you have a reflexive, infinitely looped integration of body compact feelings with body phantom events that I think that there's not much doubt that something like that is happening. And then there's something that could solve the problem of placing this within a structure that would not have at all a sort of homunculus regressing and creating all sorts of problems. And that you have the possibility of remapping all this information in heteromodal cortices. So you can have information about these basic events that are happening at a given moment, but you can remap them in cortices that are association cortices, in essence. You can generate transcripts that are really schemas of the connection of these different orders of events, and you can even provide linguistic descriptions. So at any given moment, you have not only the possibility of accessing a body state, which is your body state, but the possibility of having other events that are coming through other sensory sources, and you have the possibility of placing the influence of one on the other, and then mapping in another level of cortex the fact that the two are connected, the fact that, for example, something that you saw influenced the way in which your body is at that moment. And you have the possibility, of course, of describing that in abstract terms and describing that with language as well, which is certainly available to us. But I don't think that you need language at all in order to have first the consciousness of the experience of your body at a given moment, and then to have the experience of your body state in relation to, for example, objects from the outside world, or objects that you can be bringing back from your mind in recall. So all of those possibilities, what we call the beauty of our mental experience, is that we can, either by interacting with the outside world, or through language or through nonverbal perception, we have the possibility of having this body compact, this platform that I'm talking about, be the recipient, be the influenced party by what is coming out in external perception. And likewise, because we have a rich memory storage and we have the possibility of recalling past contents and display them in our imagination, we have the possibility of having those contents also influence that state of the body that is the platform for our mental experience. And thanks to that, I think we can integrate the operation and think about a possible way of dealing with the problem of experience. I would say in closing that the problem of mental experience is in fact the problem, to begin with, of generating an experiencer. If you do not have an entity that you can claim for the sake of hypothesis and further study, is the entity capable of experiencing or supporting the experience, you're not going to solve the problem of what a mental experience is. I do not think that, for example, attacking the problem of, say, visual experience alone without appeal to what the rest of the organism is interested in doing, I don't think it is going to lead to much. I think that when I open my iPhone, I can see a beautiful image that was produced by a certain engineering system. There are many ways of producing images like that, and there's no question the image is there. And finding out how the image is produced is not going to give you an understanding of consciousness at all. It's going to be reverse engineering on how that image is produced. I think our brains, with all their very great complexity of circuitry, are capable of producing images in auditory system or visual system or somatosensory system that are equivalent to the images that you can get through an engineered device like an iPhone. The problem is that the iPhone is not conscious, and the iPhone is not conscious because it doesn't have a life, it does not have an organism at risk, it does not have a platform that is there to regulate its life and to constitute the recipient, the interested party in everything that is going on in that mind at that point. Thank you very much for your attention.
So we will take a very brief stand-up break while we change out technology for the next speaker.